my name is Megan Newsome, and I am a third-year undergraduate at the University of Florida studying astronomy and physics. In high school, I received my International Baccalaureate diploma and passed every AP/IB course that I took and its corresponding college credit test. I volunteered as a tutor in high school and have spent the last 2 years either employed with UF or as a freelance tutor in many areas, mostly related to math and science education. Every student I have had saw marked improvement in grades and steady success because I am a big believer that nothing is out of one's reach. There's a myth that one can simply be bad at math. I think with our work together, we can prove that wrong. It's about hard work, but it's also about being taught right, and I want to handle that second part. I'll find your learning strengths, ask you specifically what you're looking to get out of our sessions, and put together challenging lessons that will make the most of our time together. So to close, I will give a mini lesson to show you what it's like to work with me in my personal favorite area, dark energy. Dark energy is a concept of astronomy, and that's from cosmology actually, related to the history of the universe and the growth of it. So the universe is made up of matter, things like you and me, even light is technically matter. Everything that has some kind of substance there, matter, right? Well, already some observations have shown that there's something more than just regular matter out there, and that is because when there are galaxies that we see out in the cosmos, we can effectively account for every star in those galaxies and how massive they are. What that means is we can say, okay, this galaxy has 1 million stars, this galaxy has 1 billion stars. We know exactly about how much every star is, mass speaking. We know how many kilograms are in every one of those stars. We can multiply that by 1 million and or 1 billion and use Newton's law of gravitation to see exactly how those galaxies should be rotating around each other. What we saw is that they are not rotating around each other in the way that the calculations show. They are not doing anything incredibly erratic. They are following normal motion rules that we are used to seeing, but they act as if there are more mass there or matter there than what we can see. So that is what astronomers call dark matter, and that it implies that there's more matter than just the stars and light and dust and everything physical that we're used to seeing that makes up you, me, and life around us. So we think it's just this dark substance that we're not sure exactly what it's made out of, and that's what particle physics today is trying to find, is what exactly is dark matter made of? Is it a different subatomic particle? Well, the next part of the universe is something even crazier. So regular matter makes up about 4% of the universe. Dark matter makes up about 21% of the universe. That's 25% of the universe. What does that mean? What's left if we found everything we can? If matter of some form, dark or not, is all we can see, what else is out there? Well, and Einstein even somewhat predicted this, but he thought he was wrong, and since then has kind of been proven right, along with a few other people. When astronomers look at really far galaxies, we can tell that they are moving away from us. And that wasn't a short time thing. We started noticing after several observations that almost any galaxy that we put our eyes on was moving away from us, with very few exceptions. The one exception we can see is our very next door galaxy, the Andromeda galaxy, and that's coming in collision with us. And that's because it's close enough with us that basically the gravity between the two galaxies is overtaking whatever else is going on. But things that are just far enough that don't have very strong gravitational pulls on each other are overwhelmed by the effect of what we call dark energy. Dark energy is really just a word we use for something that we don't know what it is. It's really spectacular because we know it has to be there. It's as if you took a balloon and drew a whole bunch of dots on the balloon, like this. That's a little not blown up balloon, right? You have a whole bunch of dots on it. I don't know if you can see it. And then we blow up the balloon, and now the dots are more spread apart. And it's kind of hard to see, but what I'm trying to get at is that the actual space between the dots themselves is what's moving the dots apart from each other. All the dots on the balloon didn't go anywhere. They didn't change position on the balloon. The balloon itself got bigger by having more space filling it up. Well, that's what's apparently going on with our actual universe around us. And we can't really explain that because all that's really out there is matter, and sure, there's lots of forces of nature, but the one kind of fundamental one that should overtake things at the end of the day is gravity. So if gravity is not able to overtake things just because of a certain distance, then there's something else going on there, and that's what we call dark energy, and that's what my research relates to. So hopefully in a few years I can have a stronger answer as to what's causing that. Anyway, I hope that helped give an insight into how I teach. Of course, as a lesson, I would be more one-on-one with you and making sure you're understanding things. I look forward to hearing with you.